Hello. In this video, we will review we will review all the sequence and series tests of right now, excluding the Taylor and McLaurin's Taylor series. So before all that, we'll review those. So yeah, let's start with number one. So number one says determine which of the following converges, and we have these multiple choice, right? So let's see. So let's start with letter A. Um, there's letter yeah, let's start with what letter A. Does this uh converges? So what we could do is do the riddle nice penguins goes camping in the Arctic region, or N P G C I T A R R. So this is a little riddle to help us which tests we can use. So on letter A, we have the summation of n equals 1 of 1 over n raised to 0.3. Um, could we could we use the nth term? I don't think so. What we could do is rewrite 1 over n raised to 0.3 as it's the same thing as 1 over n raised to 0.3. And I believe we'll just use the n stands for nth term, the p stands for p series, the g stands for geometric, the c stands for composition, comparison, integral, telescoping, alternate R stands for alternate series, the ratio, and the retest. So if you want me, that's fine. I can write it out. So this is the nth term. I don't think we'll use that. The GP stands for P series. I think we'll do that because we can write it as a P series, right? The G stands for geometric. C stands for comparison. The I stands for integral. The T stands for telescoping. The A stands for alternate series. R stands for ratio. And then this other R stands for root. So we're going to do the P series because we can write it as a P series. And the P will be 0.3, which is technically less than 1. So that you know the rule, if it's less than 1, it diverges. So this one, letter A diverges. What about letter B? Letter B, we have the summation from n equals 1 to infinity of 1 over n. So we definitely can use the P series test because it is in the form of 1 over P. So 1 over n, the same thing as 1 over n raised to the power of 1. And I believe our P is going to be 1. It's this number here, right? So P is 1, which is so the rule states if P is less than equal to 1, it diverges. So no, we want to look for converges, right? Okay, so let's move on to C. Letter C, we have this summation of n equals 0 to infinity of 3 parentheses 4 thirds raised to the n. So what test shall we use? Okay, I don't think we can write it as a P series because of, I don't think we can use a P series. I don't think we use the nth term. Can we use the geometric series? Uh, yes, we can because it is technically in the form of this. So we don't care about this number. So yeah, we can definitely use the geometric. And our R will be the number in front of the parentheses, so our R will be 4/3. And unfortunately, 4/3 is technically greater than 1. So unfortunately, it diverges. Okay, let's see D. So we have the summation from n equals 1 to infinity of 1 over n raised to 3 halves. What test shall we use? Uh, what if we just try plugging in infinity? I think we'll do the comparison test. I think, no, no, no. I think it is a p-series because, yes, I believe it is a p-series. This could be expressed as 1 over n raised to 3 halves. And our p is going to be 3 halves, which is technically greater than 1, and it converges. I mean, you could try plugging n for infinity, so that would be, you could say the limit as n approaches infinity, and then 1 over infinity raised to 3 halves is still technically infinity. What is the limit as n goes to infinity of 1 over infinity? What's 1 over a very large number? It gets to really close to 0, which is a real number. So that's why it converted. So you could use a p-series, or you could just try plugging in n for infinity. So yeah, that would be letter D only. And then letter E is none of the above, which is false. We found that D is the only one that converges. Okay, so yeah, yes, you can definitely use nice penguins goes camping in the Arctic region to help to figure out which test you can use. Number two, determine if it converges or diverges. So number two is not a multiple choice. It's just one question, and we got to figure out if it converges or diverges. So you can definitely use the riddle. Nice. Penguins goes camping in the Arctic region. Okay, so I think we can start with the nth term. Can we use the nth term? I think so. Uh, so yeah, I believe it is in a fraction, so I think we can definitely use the nth term. So yeah, let's use the nth term test. So it's just going to be the limit as n approaches infinity of n plus 1 over 3n plus 1. So if you recall, this is a fraction, and what is the limit of a rational function? It's the horizontal asymptote. So what's the highest term on the numerator? It is n. What is the highest term on the denominator? It is 3n. And what are the degrees? This has a degree 1, this has a degree 1. So the rule states if the degrees are the same, you just use the coefficient. So it's actual number 1/3. So we know it diverges to 1/3. So yeah, our answer is diverges because if we get an actual number. Okay, that wasn't too hard. Let's move on to 3. Number 3 says determine if it converges or diverges. And we have the summation from n equals 1 to infinity of negative 1 raised to the n over square root of n. So I think we could use the alternate series test. So yeah, nice penguins camping. If you have to write out this riddle, that's fine. So I don't think we'll have an n series. I don't think we'll have a p series. I don't think we have a geometric comparison. What's the other one? Integral telescoping. I think we'll use the. I see a negative 1, so that's definitely we're going to use the alternate series test. Yeah, I think we'll do the alternate series test. Because we have a negative 1 raised to the n. So what I would do is, if we're going to do the alternate series test, I will pull out the alternate part. So pull out the negative 1, and now we're left with the summation of n equals 1 to infinity of 1 over square root of n, right? And then what we could do is we can write it as the limit, which is infinity of 1 over square root of n equals, yeah, then what you could do is just replace your n with infinity. So what's 1 over square root of infinity, which is technically 1 over infinity, which is 0. Okay, so yeah, so we know that this definitely converges by the alternate series test. But does absolute convergence or is it conditional convergence? So we know it converges by the alternate series test. But sorry. So but does but does it absolutely converges or is it a conditional convergence? So let's figure that out. So the absolute, we can rewrite this as n equals 1 to infinity, and then we'll just use the absolute value of negative 1 raised to the n or square root of n. And then you can use the p-series test. So this is equal to summation of 1 square root of n. So uh, then you can use the p-series test. Okay. So we have the summation of 1 over n raised to the 1/2. And our p is going to be 1/2, which is less than 1. So we know it diverges. Since we have a convergence and a divergence, it's a conditional convergence. Okay, so since we have a convergent, it originally convergence using the alternate series test. Um, then we applied we tried to figure out if it was an absolute convergence by putting the absolute value, and then we used the p-series test, and it diverges. So if you have both a convergence and a divergence, we know it's a conditional convergence. Okay, let's move on to 4. So number 4 says determine if it converges or divergence. We have in summation from n equals 1 to infinity of n over square root of 2n squared plus 1. So which shall we use? So yeah, which test shall we use? So we have nice penguins goes camping in the Arctic region. So I don't think we use the nth series. I don't think we could use the p series. I don't think we could use the geometrics. But I believe we could use the comparison because it is technically a rational function, right? So yeah, we can't use p series because we don't have 1 over n raised to the n. We can't use geometrics because it's not r raised to the n. But we definitely use the comparison because it's an irrational function. So right, so what we have is we can rewrite this as limit as n goes to infinity. And then what's the highest term on the numerator? And what's the highest term on the denominator? Be careful. This is the square root of 2n squared. I don't care about this one because I know this is a very small degree, so don't worry about that one. So what is the square root of 2n squared? That's the same thing as the square root of 2 is the same thing as 2 to the 1/2. The square root of n squared is n, right? The square root of n squared is n. So what you could do is take out this rational. I mean, this not right. This constant 2 to the 1/2 is the same thing as 1 over square root of 2 times 1 over n. Sorry, there's a mistake on this problem. It should be a 5. There you go. So this should be 5/2. And then you can so this, sorry, my, yeah, my bad. Yeah, so this is square root of 2 and 5. So now this is, what's the square root of n 5? It's the same thing as 5/2, right? Now, did you know we can rewrite this? Now we can rewrite this as a p-series because now you have 1 over square root of 2, and then you could simplify these n1 over n5, right? Um, because they're the same letter. So when you're dividing with the same base, you are technically subtracting. So 1 minus 5/2, I believe that is going to be 3/2. So yeah, 1 minus 5/2, yeah, it would be 3/2. Or what is it? 2 minus 5 is negative 3/2. So that's the same thing as 1 over n to the 3/2 on the bottom because this is negative 3/2. And that could be expressed as 1 over n to the 3/2. Parentheses 1 over n raised to the 3/2, right? Now we have a p-series, and we know that the p is going to be 3/2, and it's technically greater than 1, so we know it converges. So now you're going to have to prove it by comparing it. Yeah, so now the next step is we got to prove it by comparing it. So how do we compare it? We write it as the limit as n goes to infinity. And then it was n over square root. It was originally n over square root of 2 and 5 plus 1. And then what we do, we times it by the reciprocal of this, or the highest term on the numerator, the highest term on the denominator is square root of 2 and 5, and then yeah, we just multiply the reciprocal of this. So it's going to be a square root of 2 and 5 over n. And that becomes, that just becomes 1. So, and then conclusion, since n over square root of 2n to the 5th converges, and then n over square root of 2 and 5 plus 1 also converges. Okay. Okay. Let's move on to question 5. So number 5 says determine if it converges or diverges. And we have n equals 1 to infinity of 1 over n times ln to the third. So what test shall we use? So we can use the riddle nice penguin goes camping, and she goes camping in the Arctic region. So let's see. So if we try the nth term, it'll equal to 0. So we can't, yeah, I don't think we use the nth term. Can we use the p-series? I don't think so. There's no way I can rewrite that as the p-series. Can we use the geometric? I don't think so, because it's not raised to, I don't see a -1 raised to the n, right? We don't think we could do the comparison. Uh, yeah, I don't think we could do the geometric. Uh, could we use the comparison? Maybe. Could we use the integral? I think we could do. I think we could. I think we can definitely can use the integral test. Um, yeah, I think we'll do that. I also think we can also use the. I think we could also use the comparison test because it's technically in a rational form, right? But the reason why I think I'll use the integral test first is since positive term is decreasing and easy to integrate, and we have ln. So the reason why we're using the integral is because it's a, since positive term is decreasing, since decreasing and easy to integrate. And we have also an ln, so maybe that's why I'll use the integral test. So yeah, we're going to use the integral test so we can say the limit as a goes to infinity of 1 to a and how should we use this? How should we solve this integral? Well, I think we'll have to use substitution, right? And what do you think our u will be? Yes, I think our u is going to be ln. So we're going to use substitution, and our u will be ln. And my du is going to be ln of n. And then the integral of that was the integral of ln is 1 over n dn. And yeah, I don't think we need to get rid of anything because we have 1 over n dn, so we're good. So we're going to rewrite this as the limit as a approaches infinity of 1 over n, then just replace u with, replace l of n with u. So this is going to be u to the third uh, dn. I mean, du. Do next. Oh, no, we have 1 over n dn. What you could do is replace that with du. Do you see that? So yeah, we have when we take the derivative of ln of n, we get 1 over n dn. Now you can just replace that with du. So you don't really need this 1 over n. So now you have the limit as a approaches infinity of, let's see, we did have boundaries. It was originally 1 to infinity, right? But because we did a u substitution, you can change your boundaries. So let me double check. You have 1 over u cubed du. And then, yeah, you can change your boundaries now because we did a u substitution. So if you plug in ln of 1, that gives you 0. And if you plug in ln of a, uh, that's just ln of a. So your new lower boundary is 0 and your upper boundary is ln of a, right? Okay. So we have the limit as a approaches infinity. And then from the integral from 0 to ln of a. And then we can rewrite 1 over u cubed is the same thing as u to the negative 3 du. And we can easily take the integral of u to the negative 3 by using power rule. So it's just old power plus 1, negative 3 plus 1 is negative 2, divided by that power negative 2. So that is the same thing as negative 1 over negative 1/2 to u squared, right? We can write this as the limit as a goes to infinity of negative 1/2 to u squared, 0 to ln of a, and then that equals to the limit as a approaches infinity. And then you just apply your upper minus your lower, so it's going to be negative 1/2 to ln of a squared minus 1 over, and then do the lower boundary, so that would be 2 over 0 squared. So over here we kind of have a problem. What's 1 over 2 parentheses 0 squared? That's undefined. That makes this undefined. So the whole thing is undefined, so it's divergent. So it is definitely divergent. I'm going to stop here. We'll do a part 2 on another video.